how we ever acquired these complicated pink bundles commonly known as the muscular system? Hi, my name is Jerry Tendon. I am here to discuss with you the evolutionary trends of the muscular system in lower life forms. You might ask me, why do we need to learn these evolutionary trends? Well, first of all, our muscular system is very complicated. In order to fully comprehend it, we must know and understand the muscular systems of lower life forms in order to trace and fully understand our own muscular system. Secondly, if you want to be a biologist, you need to understand the different life forms, the different muscular structures of lower and higher life forms. And thirdly, I was assigned to do this assignment, so you probably have no choice but to listen to me. Okay, so let's start. Cnidarians, like other animals capable of locomotion, they possess muscle and nerve cells. Here, this is an example of a cnidarian. This is a jellyfish. In its structure, it is composed of muscular and nerve cells that makes it move. Okay. Next, we have mollusks. Yes, mollusks. The locomotion in mollusks is less efficient than the other groups of terrestrial animals, such as arthropods and vertebrates. Example of mollusks are snails and slugs. Okay, so third, arthropods. Arthropods. What are arthropods? Arthropods are insects, spiders, yeah. They use jointed appendages, here you can see here jointed appendages, that act like a system of levers and are ideal for any activity that requires movement. So here, the center of gravity must not be destroyed, or there must be a center of gravity, or else the balance of the arthropod will be lost. Okay, so next. Vertebrates. Vertebrates are just like the arthropods. Yeah, the arthropods, joint appendages. Yeah, vertebrates. Vertebrates. Okay. Okay, next are animals like grasshoppers that do not walk on land. So the grasshoppers, the muscles of the grasshoppers work in pairs. When one muscle contracts, the other relaxes. When one muscle relaxes, the other contracts. This alternate movement makes the grasshopper leap. That is its movement. Okay, next. Snakes, annelida. Okay, annelida. The locomotion in the earthworm, an earthworm is an example of an annelida, is suitable in its way of life. So the earthworm, here, look at, the outer part is composed of the circular muscles. The inner part is composed of the longitudinal muscles. The circular muscles, when the circular muscles contract, the worm becomes longer and thinner. When the longitudinal muscles contract, the body of the worm becomes shorter and thicker. Since the body cavity of the earthworm is filled with fluid, when the muscles contract, the fluid stiffens the body. So when the body is stiffened, the earthworm is enabled to push through the soil. Okay, next. Snakes, caecilians, and other legless amphibians. They use peristaltic motion to slide over the surface. Most snakes employ serpentine locomotion, in which the body is thrown into a series of sinuous curves. Next, please. The fish. The fish makes out the muscle contractions of the fish have alternate movement in the left and in the right. With this alternate movement, the body is enabled to push against the water, thus making the fish move forward. There you go, the fish. Okay, locomotion in birds. The movement in birds, okay. The raising and lowering of the wings is achieved by the alternate contraction of extensor muscles or elevators and flexor muscles or depressors. So there's an alternate contraction in order for the wings of the bird to flap and enabling it to fly. Okay, and last, mammals. The mammals developed muscles and generally have 4 limbs attached. So we are mammals and we have 4 limbs attached. So basically those are the general trends of the muscular system in lower life forms. This is Jerry Tendon. Thank you for listening and good night.